Okay, so from last time, I left off at the end. There was a mistake. I couldn't find it, and I said, "Okay, guys, go on leave and all that." Remember. But anyway, I found the mistake. I corrected it on here, but it was right here when I was going through this. I dropped off a negative sign when I did the integration here. I think I dropped off the negative on the 3 here, perhaps. I don't know if you've seen your notes, but when I did the integration there, I lost negative sign there somewhere. Okay, but it should be a negative there. And then it works okay if you have the negative there. So it shouldn't end up, it should be a negative 2/3, not a positive 2/3. That was the problem. And so, okay. So I don't know if you guys found that or you did the problem yourself and got the right answer anyway, despite me, but okay. Anything there on that? Okay, so I'm going to do some more examples here. So a couple more. This is the last one, linear. So you solve the initial value problem. Okay, let's do this one here. So xy prime minus 8 over x is equal to 6x minus y. Okay, and let's say 1 comma 0. It goes to the point 1 comma 0. Like this here. Okay, so looking for a solution goes through that point 1 comma 0 here. All right, first of all here, right, you come over rearrange this so it looks like a linear equation. So everything's all kind of scrambled around here, right? So basically, right, you want to move move this over to the right, move this to the left. You may start by doing that. Okay, so it's a linear equation kind of in disguise there. Oh, also I'm going to say here, assume x is greater than 0. I'll throw that in here too. We're just going to look at x greater than 0 here. But anyway, if it kind of unscramble it, see if I get this right. Right, so if you can write it like this instead. Okay, because typically we have a linear equation, right? You have your y prime, and then the y, and then your function of x over here, like this. Okay, and then finally here, and one more thing you want to do, because remember, linear equation, it looks like, right? It's like this here. Like you want to have like y prime plus p of x, y equals, I call it f of x, I guess. I don't remember, but like this here. This is like a linear equation, right? It looks like this. So you want to kind of get it in this form to start, right? This is like a linear ODE. Okay, like this. So you want to take this one and write in this form so you can recognize it as a linear, right? So you get like this. And then next up would be what? If I'm trying to get it like this, I would do what next? I'm trying to get in this kind of form. Divide by or multiply by 1 over x, or right, divide the x across. So basically you get this then, y prime plus 1 over x y equals, and this is a 6 plus, you could say 8 over x squared here then. Like that. We're assuming x is greater than 0, so no division by 0 problems here or anything. Okay. So anything there so far on that? Now, once you have it like this, okay, you want to look for solutions like this now. So if you're looking for solutions to this, like we talked about last time, you want to look now for solutions or let me say look for solutions like this. Look for y equals, okay, it's e raised to the negative integral p of x. Or I'm sorry, one more time. Look for y equals u, which is a function of x, okay, times e raised to the negative integral p of x dx. Okay, so to help solve this, okay, we'll look for solutions like this here. Look for solutions of this form. Okay, where, yeah, so that'd be what here then? Well, we have u of x times e raised to negative. What's the p of x here? Right, that's back up here looking at the differential equation up here, right? The p of x, right? That is this right here. It's the 1 over x, like this. So negative integral 1 over x dx, right? So we'll look for solutions like of this form here. And then you want to simplify this out. See what this is here? Okay. And now how that go then? This is, I'll come back down here maybe. This is equal to what? U of x. Now this is e. Now this is what? Negative. That'd be natural log absolute value of x. Like this. Okay. Now you could look for solutions like this here, but you can actually simplify this a little bit. So it's not so messy. For one thing here, we have this. I have this assumption here: x is greater than 0. All right, which means here then I can write this. I can drop the absolute value there because I'm assuming x is greater than 0. So, okay, so I drop the absolute value off of that. Okay, then equals further here. Now watch this here. See if this makes sense. This is kind of the tricky part. Okay.
Isn't e the natural log? Doesn't it cancel?
Well, except for the negative up here. I got to watch for this negative. Yeah, I got to deal. I want to deal with that negative first before we cancel. Right. See if you agree with this much here. Right. So this would be the same as this. Okay, I just put a negative 1 in front of there, right? Okay, and that's equal to u of x. Now here's kind of the trick here then. See if you agree with this. You have to know exponent rules here. Okay, right? Because if you have a power to a power, you can multiply the exponents together. So right, so this is this, right? Okay. That's kind of the trick there. Use exponent rules, get that negative 1 up there. Now, what's this guy right here then? This is x, right? This is x here. So this is equal to, you get basically u of x times x to the negative first, like that. Okay. And actually, normally I like writing it as 1 over x, but I'm going to leave it as x to the negative first. Okay. You can write it just for reference. Maybe I'll write it both ways. But it's the same as this if you want just for reference, right? So we're looking for functions like this, right? So look for, if I summarize that, look for this, functions like this, y equals u x to the negative first. Use a function of x here. I'm just kind of suppressing that here, though, because I don't want to drag that around all the time. But use a function of x here. So we're looking for solutions like this. Okay. Okay, anything else so far on that? It's just a little detail there, kind of going through that. But, okay, now what you do then, once you have that, now you go back to your differential equation, right? So let me write that down here again. So we got what? Y. So we got y prime. I'm just going to recopy the equation here. Plus 1 over x y equals 6 plus, I'm going to actually write this as 8 to the 8x to the negative second for now. Okay. So I'm basically going back to the differential equation here. Okay, just kind of recalling what it was. Okay, and if you're looking for solutions like this now, what you want to do is take this and substitute that into here. So you substitute it in here now. Okay, so now first thing here, you got to find y prime, which is like dy dx there, right? So if I substitute in, right, so now you basically sub into this now. Okay, and now y prime then, what would that be? You have to use a product rule here because you have a product of two functions of x, right? So y prime would be what? You take the derivative of the first part, right, which would be u prime. You keep the second part just like it is, okay, plus, now this time you keep the first part and you multiply by the derivative of the second part, which is this, with respect to x. So what's the derivative of this one? That'd be negative 1x to the negative second. Right, so that's using the product rule to take the derivative. You're substituting in here. So this, the y is this, then use the product rule to take the derivative. You get that. Okay, now plus, Okay, now this 1 over x, that's x to the negative first. I'm going to use a lot of negative exponents here for this. This is x to the negative first. Now, what's the y? The y is this right here, right? So u x to the negative first, like that. Okay, then equals, then we have the stuff over on the right, 6 plus 8x to the negative second. Okay, anything there so far? Now, the thing that will always happen here, okay, if you do this correctly, you see how these guys cancel. If you look at this right here now, this is like ux in negative second, right? So that's ux in negative second, and then you have the negative of it over here. Okay, these two actually cancel now, so those will cancel. Right? So now we have this, that u prime, or yeah, u prime there, x to the negative first is equal to 6 plus 8x to the negative second, like that. Okay, and now if I look at the u prime by itself, get the u prime by itself here, so I can multiply through by what? By x to the first power. Multiply both sides by x to the first. That makes us a 1 here then. So multiply through by x to the first. So I get then that u prime is equal to what? That'd be 6x to the first plus, and that'd be 8x to the negative 1 here now, like that. That's multiplied through by x to the first on both sides, like that. Right, so by x to the first, by x to the first. Okay, again, I'm using a lot of exponent stuff here now. Now, this is what then? I can write this now. This is now what? Du dx is equal to 6x plus 8x to the negative first, like that. Okay, let's get this here then. Well, it's like a separable thing. It's really separable because I can just move the dx over here. And basically now I can just integrate. I can just say now u is this. U is just going to be the antiderivative of this now here. Okay, so you just find antiderivative here. So that would be what, like 6 times 1/2 x squared plus, and then this would be 8 times. Now this is 1 over x. So it would be natural log absolute value of x there. But we already said earlier that x is greater than 0. We're just looking at x greater than 0. So I can just write this. You could have the absolute value, it doesn't matter. You can have it there, or you don't have to have it there, because we stipulate x is greater than 0 in this. Okay. And then don't forget the plus c here, like that. You have the plus c. So then we got that u is equal to 3x squared plus 8 natural log of x plus c. That. Okay. So now recall then, I'll say here, recall that what we're looking for solutions like this, y is equal to u times, and what was it, u times x to the negative first. Okay. So we have here then y is equal to, the u is this. I'll write x to the negative first here first. Right, so we found a u here that makes it work. Right, if u is this, then that differential equation holds there. Okay, so then recall that. So we have y is equal to this. This is the u right here, and then the x to the negative first. I wrote that in front here, and then finally, that's okay there. Or you can distribute the x to the negative first through it now, right? So you get 3x plus, and this would be 8 natural log of x over x. I'm putting it back like this now. Plus, and then this would be you can say c over x here then, or c x to the negative first. That's multiplying x to the negative first through. Okay, so this is the general solution here to the problem. Okay, but this is actually an initial value problem here. Okay, we wanted to look for, we had condition here, right, that it goes through the point 0, 1, right? So it goes through the point 0, 1. So I would say 1 is equal to 3. What was I? Oh, thank you. 1, 0. So that would be 1 equals 3, wait, 1 comma 0. So 0 equals 3 times 1 plus, and then this is going to be, now what would happen here if I put 1 here? Yeah, I guess it's 0 because natural log of 1, 0. So that actually becomes 0 there. Actually, I'll just write it in just to see it. Right, so then 0 is equal to 3, that's 0 here, plus c. So c would be -3 here then. Right, so finally here, the solution would be this, be y equals 3x plus 8 natural log of x over x minus 3 over x. Because that'd be the solution then to the initial value problem. Okay, so anything there? And let me just show it on GeoGebra real quick to see the slope field, just to see if it holds. Okay. And hopefully I'll have better luck this time. So stop sharing here. Let me share back here. Okay. And new tab. Okay, so start calculator. And let me share the screen here. Okay. Back to this. Okay. So then I'll do slope field. Now we do slope field, right? It's assuming you have dy dx on the left side and then everything else is on the right side. So you kind of have to, I'd have to move things around here a bit, I guess. So I think it would be like 6. Yeah, it'd be 6 plus 8 over x squared. Oops, 8 over x squared. And then I'd have to subtract over the y stuff. So it'd be then a minus, it'd be like y over x, I guess. Y over x. Okay, so here's the slope field. I don't know, it's not very interesting. Let me see here. Make sure I got that right. So 6 plus 8 over x squared minus y over x. Okay, well, let's see what the solution is. So according then, we have this, what? Y equals, was 3x plus 8 times natural log of x divided by x. Okay, and then our particular solution here is minus 3 over x, like that. Okay, and then there's the solution. Okay, so you can see it there. I guess it's not very interesting. Yeah, but it follows the slope field there, so you can kind of see it follows it there. If I make it like a constant c here instead, if I can make a c here instead. Oh, and the initial value, I'll plot the point. It was 1 comma 0, right? 1 comma 0. So that curve, it goes through, right? It goes through 1 comma 0. So, and zoom in. But there's the, not a very interesting one, but that's the solution there. Okay, if I change this to like a c here, like an arbitrary c, okay, then I try, is there a slider I can do? Where's the slider? I thought I'd make a slider or something, but let's see. Get rid of this. Okay, I'm gonna move on here, but sometimes they'll put a slider there automatically. I don't know why it's not putting a slider for me. But anyway, you can change the value of c here to something else. Say like, for instance, 1. Like there's no solution curve here then. So, but anyway, if I get the slider to work, it would get other curves here. know. Okay, but anyway, that's the solution there for it. You notice it follows a slope field on it. Any questions in that one? So, okay, so let me share back here then. Okay, and back to this. Okay, so okay, so let me go back here. Okay, so that's the end of that section. That's what I'm going to do for linears. So that's how you do linear equations there. Okay. Next kind of equation to look at, it's called Bernoulli equations. Okay, so this is like section 2.4. And I'm kind of skipping over 2.3. I'm skipping over 2.3. You can read it if you like, but I'm not going to spend much time on 2.3. So let's go on to 2.4. But 2.3, Bernoulli equations. This is another kind of differential equation here. Okay, so let's see. Back here. Here's a Bernoulli equation. It looks like this. A little different form here. Okay, so it looks like this is the start. Okay. Now, if you look at this here, this is just a linear equation. Okay, this is what we just did, was this. Now, Bernoulli equation, okay, it tacks on another thing over here then. It's f of x times y raised to a power, like this. So it's a little more complicated. Now, okay, now we have this here. So it's y raised to power, okay. Yeah, like this. So this is called a Bernoulli equation here then. Now, by the way, if r equals 0, that means then like this would be a 1 right here, and it'd be linear again. So if r equals 0, or if r equals 1, it's also linear, because if r is equal to 1, then I can move this over here to this side and get 0 on the right. So if r equals 0, r equals 1, it's linear. Okay. So just kind of note that there. So if r is 0, r is 1, it's really just a linear equation at that point. Okay. But anyway, we're going to look at ones like this here now. Okay. And basically on this, it turns out you can pretty much do the same thing as we did in the linear ones. You look for solutions. Of form. Same thing again, y equals u times e to the negative integral p of x dx, just like before. Exactly the same thing here. Okay, so let's just look at an example. Let's start with this one here. Let's say dy dx minus 1y is equal to e to the x y squared. So we'll try this. So we'll find the solution. I'm going to solve this equation here. So I'll say solve. So basically, yeah, like I said, it's kind of a miracle, but it's like the same process, pretty much. The same process here you can do. It gets a little more complicated at the end. But okay, so yeah, so basically look for what? We want to have look. So I'll say here, look for what y equals u. Remember, use a function of x here. E raised to the negative integral. And then what's the what would go here then? -1. That's the p of x, right, from this up here. So -1 dx. So that's going to be what? U times e. Now, of course, then basically here, this becomes e to the x, because the negative, you take the negative out, right? The dx just becomes an x. Then so it just comes like this. Right, so look for solutions like this. Okay, so anything else so far? Okay, so now basically now sub this into, so in other words here, if I short, right, I can write like this here. So basically, i.e. look for this here. Okay, now sub that into the differential equation then. And we're going to try to find a u that makes it work then. Sub into the diffyq. Okay. So if we do that here then, now first thing it calls for is what? Dy dx. Okay, so if I sub that in there, again, I can use the product rule. So you take the derivative of the first part, that'd be u prime. Okay, you keep the second part just like it is. Plus, now this time keep the first part and multiply by derivative of the second part. So derivative of e to the x is what? E to the x, right? So it's e to the x. Like that. And then keep subbing in here. And then minus, now I don't need the 1 there really, but minus what? Minus y. What's y here? Y is this. Like that. Okay. Equals. Now on the other side, sub in. So you get e to the x. And then now you got sub in here. So the y there is what? That's u e to the x. So then it reads like this. Anything there so far? Now, once again, okay, these cancel, right? So there's a cancel there. Okay, and then you end up with this. You get u prime e to the x equals e to the x, and then a bunch of stuff here. It's okay if I write this maybe then as, I can use exponent rules. This is u squared times e to what power? Well, yeah, yeah, I could do that. I would say 2x, but I'll write 2x for now, but I'll write 2x for now. Okay, just for a minute. I may regret that, but write this e to the 2x for now there. We got that. Okay, anything there so far?
I am wondering.
Yeah.
You set this up to always get a cancellation.
Yes.
So
yeah, the cancellation like this, it works nice for linear equations and for Bernoulli equations. Okay. Other ones we do later, it won't. We'll have to do another way. But for linear Bernoulli, you can do this. Yeah. Okay, so you get this here then. Now you notice here they can simplify this sum, right? The e to the x's, you can divide that away, right? That there's e to the x there. Okay. Yeah, so then you get what? Y prime is equal to u squared e to the 2x. Okay, like this. Now at this point, if I look at this, right, I get du dx equals u squared e to the 2x. At this point now, you always get a separable equation. This is now separable at this point. Okay, notice this is separable. So when you do this process here for Bernoulli, you'll get a separable. Okay, you notice here when we did it linear, it was nicer if linear because we didn't have the u over here. Okay, we had a linear equation. Okay, but now we got to actually do a separable, a little bit more work now. So basically then it goes like what would have, I could say u to the negative second du is equal to, that would be e to the 2x dx. Again, I'm kind of favoring negative exponents now for this, okay? So I divided it over, or both sides by u to the negative second, or 1 over u squared if you like. Now antiderivative, now you take antiderivative of each side. So now this will go what? That'd be u to the negative 1 over negative 1 equals, and then over here, antiderivative here, what do you think on that one? It's 1/2 e to the 2x, right? That's 1/2 e to the 2x. You can check by taking a derivative. If you take derivative of this, you get this. You have to use a chain rule to take the derivative there. But yeah, antiderivative would be this one. Anything on that part? Okay, and then don't forget the plus c here then. Let's get the plus c. Okay, and now I'll multiply through, but I'm going to solve for u here. So I'm going to multiply through by negative 1. So that gives me negative 1/2 e to the 2x. I'm going to write minus c for now. I'm trying to respect the constants a little bit more here instead of lumping them as much. So I multiply through by negative 1. I get this then. Okay. And then So this is like 1 over u here, right? So that's 1 over u. So basically, kind of, if you just reciprocate both sides now, you can write u is equal to 1 over negative 1/2 e to the 2x minus c. Right, so that's the u here then. So finally then, now recall, right, what was, that's the u, right? So we found a u that makes that work. So recall then that y is equal to u times, was e to the x? I think, is that, or yeah, e to the x. Okay, so, right, we got that y is equal to, and then that would be, basically it's just e to the x over negative 1/2 e to the 2x minus c. It doesn't matter if you call it minus c or plus c, you know, that part doesn't really matter. So, okay, but that would be the, that'd be the solution there then for it. So anything on that? Let me try that on GeoGebra just to see it, what it looks like. Hopefully this one's a little more interesting. So share back here. Okay, and share screen. May get the slider to work this time. Let's see. Try this again. So I'd say here, yeah, okay. So I got a slope field. And where's my equation there? Okay, so I got everything to one side to do this. So it'd be e to the x, e to the xy squared. What would be the rest of it? Yeah, plus, we got to do plus y. Basically, we use slope field on here. You get dy dx on one side, and then use algebra, move everything else to the other side. Okay, so plus 1y, yeah, or just plus y, right? That's the slope field for the differential equation. Basis algebra can solve for dy dx, and then get everything to the other side. Okay, so here's the slope field for it. A little more interesting there. Okay, so some strange things going on there. But anyway, we got y equals, I'll say e to the x divided by negative 1/2 e to the 2x. I'll try minus c. There we go. Now I got a slider. Okay, so I put it minus c there. I can use a slider here. So you need different solution curves here then. So you can see some of them there. And then yeah. So anyway, so there's just some different solution curves there for it. So okay, anything there? Let's see. Oh, okay, so those are some of the curves there. So okay. Yeah, all right. Let's see. Okay. See, like this one, for example, here, I think what happens here, the denominator actually goes, if you do this here, for some value of x where it blows up, the denominator is actually 0 here. If you pick the right value of x here. So there's like this could be like for certain x here, you get like a vertical asymptote there because this could blow up here with this particular choice for the constant. Because this could, if you pick the right x, this could be a 0 down here, and you can't divide by 0. Okay, so that's why it has like a vertical asymptote here, and it kind of moves around. But that's because of this down here. So, but anyway, these are all the different curves here though for it. So, all right, anything there? Okay, So that's that one. And let me go back here. Share back to this one again. Let's do another one here. Let's try this one here next. Yeah, okay. Let's say solve the initial value problem. Solve the IVP. Y prime. By the way, I'll just mention on that last one there with the vertical asymptote, that goes back to the interval validity we talked about, like the interval validity, right? So you kind of restrict the interval validity. We're not really going into it, but you'd have to say there's one interval validity and then the other interval validity because you have to look at them kind of separately, if you want to talk about the solution as a function. But that's like a more of a technical thing that we got the solutions there, but you can pick out certain curves if you want then for the solutions. But anyway, let's see. Okay, so now what? So we'll solve the initial value problem here. Okay, so again, look for solutions of the form. And this is basic in the right form already for Bernoulli. Right, so look for what? Look for be y equals u e raised to the negative integral, and then that'd be what here then? -3, right? Dx. So that's u e to the so that'd be 3x. Yeah, 3x, just that. I was thinking about logarithms and stuff, but you don't need that here, right? So it'd just be like this. We're looking for solutions like this, right? Y equals u e to the 3x. Actually, I could better plug this in real quick, my computer, because this screen just dimmed on me. And then you plug that into the differential equation there, right? Let's see what happens. There should be a cancellation that happens. So, let's see here. There we go. Okay. Let's see. Now I can just about shut everything down. There. Okay. So substitute that in then. I'll say so subbing here. So it goes the same pattern. Right? So you put here, so that'd be find u prime. So you use a product rule there. So that's u prime e to the 3x plus. Now you keep the first part. And what would be the derivative of the second part? So derivative of this. So it's the derivative of e to the 3x. Yeah, 3e to the 3x. Okay. So I'm using chain rule there to take the derivative. Okay, so I got that. So 3e to the 3x. Minus then 3 times the y is this again. So that's minus 3u e to the 3x. Then equals e to 2e to the 4x y squared. Like that. Okay, anything there so far? And these will cancel here again, right? So this cancel. Anything there so far? Good time to ask a question, if any questions.
I'm forgetting how to do the info.
Oh, okay. Actually, we're doing the derivative, right? So, so we're taking the derivative of e to the 3x at this point right here. Okay. So basically, the derivative of e to the x is e to the x. Right. Okay. So you have to use a chain rule there. We take the derivative. So d dx of e to the 3x. I'll write this down necessarily, but so take the derivative here. Basically, I think of it like this. You take derivative respect to treat this like a something, like the u, like a something up here. So derivative of e to the something is e to the something because e has its own derivative. And then I multiply by the derivative of the something. So times 3. Yeah. Yeah. Okay, so yeah, that's the chain rule there. Okay, so you get this. And now what? So we got u prime e to the 3x equals 2 e to the 4x y squared, like that. Now, a couple ways to look at this. You can divide both sides by e to the 3x, or you can think of it like this: multiply both sides by e to the negative 3x, right? So if you multiply both sides by e to the negative 3x, that just becomes what? U prime equals 2. Now this from, if you multiply, you e to the negative 3x here, you add your exponents, so that just makes e to the 1x, right? You get basically e to the x there then y squared. Am I thinking that right? It'd be e to the negative 3x on both sides, right? And then you add your exponents. So 4x minus 3x would be 1x. So it should be that there. Okay, and anything there so far? There's going to be a lot of exponent rules in this too. So deal with the exponent rules. Okay, now at this point, once again, you have a separable. Oh, wait. Up. Back here. Okay. So I didn't substitute over here, did I? I want to substitute that in, which I didn't do. So that should be, where'd it go? Yeah, okay, right, y squared. That's u e to the 3x squared. I forgot to substitute in over there. Everybody see that, what I didn't do? Okay. Thanks. And then now let's go change all this down here now. And so then now here, I guess I use exponent rules here then. So that'd be what? U squared times e to what power here now? E to the 6x, like that. Now I go through by e to the negative 3x, and I get what? 2, that's what? 10x over here, e to the 10x. I think e to the 7x, or u squared e to the 7x. Is that right? I think, yeah, e to the 7x. Right, I'm multiplying by e to the negative 3x here, e to the negative 3x over here. And then you do exponent stuff. I see it this. Anything else there on that? Now at this point, now I have a separable differential equation. Okay, so right, because it's like du dx equals 2u squared e to the 7x. Okay, and so then now separate it out. So I'm actually going to go, I'll write like this. I'll say, what do I say? I'll say u to negative second du is equal to 2 e to the 7x dx. Right, I move the dx over, and I multiply both sides by u to the negative second. Okay, separate it. Now integrate both sides. This becomes what? U to the negative first divided by negative 1 on that side. And now this is, how about over here? What becomes of this? So if you integrate it. Well, okay, now we're doing antiderivative here. It's 1/7 e to the 7x, right? Okay, so that'd be, and then don't forget the plus c here, like that. Okay, anything there so far? Okay, so yes, the antiderivative there. The 2 can come out and then antiderivative there. Because if you take the derivative of this, right? If you take the derivative, you will get this back right here. If you take the derivative of this, you will end up with this. Because the 7s will cancel. right? If you take derivative of this, you will get this. So, okay. And now finally here, we'll solve for the u. So multiply through by -1. So that's -2/7 e to the 7x minus c now here. And then do the reciprocal thing again. So u is equal to 1 over -2/7 e to the 7x minus c. Okay. And now recall that y is equal to u times, what was our u times u to the 3x, right? Right. So now we have y is equal to, it'd be e to the 3x over this down here. Like that. And actually, this was initial value problem too, so we're not quite done yet. But we got this here. So we got the solution without regard to the initial value yet. But anything there so far? And then finally, it was what, y of 0 equals 1. Is that the condition? I don't remember. Oh, y of 0 equals -1. Okay. So y of 0 equals -1. So then I get -1 equals e to the 3 times 0, 7e to the 7 times 0 plus c. So -1 equals, that's 1 over -2/7 plus c. Or is it minus, or wait, it's minus c. This is again where you can change it to plus c in it at some point there. And you know, but anyway, I guess I got minus c here. So then you solve this here. I guess I can multiply this over. Okay, so so that'd be like 2/7 plus c equals 1. Right, so I multiply both sides by this here and distribute the -1. So then you get, I think like c is equal to 5/7 you would get. So finally, what we get, y is equal to e to the 3x over -2/7 e to the 7x minus 5/7. Right, so that'd be the solution then to the initial value problem. Okay, anything on that one? Going through it? They're not too bad, right? No, they're not too bad there. So, okay, got one more to go with these here. Okay. So let's try this one here now. Let's say x dy dx plus 2y is equal to x squared over y cubed. And a couple assumptions here when we're solving this. We'll assume here that x is greater than 0. And also assume here, we'll make the assumption y is greater than 0. That avoids issue with division by zeros and stuff like that. Okay. Okay, so we might use those assumptions as we go here. So at some point, if we can simplify things as we go by assuming this, we'll do that. So, okay. Okay. So now first thing here would be what with this one? You got to get in the right form, right? So here you would do what? Start by doing what? Divide through by x, right? Divide through by x to get rid of it in front of here. So then you get dy dx. We're assuming x is greater than 0, so there's no division by 0 problems here. 2 over x, y equals, and that becomes just x. I'll write it like this maybe, xy to the -3rd. That's okay there. So I divided through by x. I did a negative exponent thing there. Okay, and anything there so far? And what, right, one of the x's cancels, makes x to the 1st. So we got that. And now we're going to look for Okay, so look for what now? So look for solutions like this. Y equals u e to the negative integral of what? Yeah, 2 over x dx, like this. This one's a little bit messier than the last one. It's more like kind of one we did earlier. But what this is, then u e to the negative. Now this is 2 natural log. I can say 2 natural log of x, because I'm assuming x is greater than 0. So I can drop the absolute value off. Now, if I assume x was less than 0, right, I'd have to put a negative there somewhere. When I drop the absolute value, it'd be like a negative x instead, right? If I assume x were less than 0. But anyway, I assume x is greater than 0, so I get this. Okay. If you go through the same sort of thing we did, this becomes u x to the negative second. That's okay. Because if you do the exponent rule thing, I'll just kind of show you again real quick, right? But it's like this. You can write like this here, right? By exponent rules, right? This guy you can write like this, because you multiply your exponents together here, right? If you take this times this, that's this. And then this is x right here. So you can go from this to this, like that. So we're looking for solutions to this form here then. Anything here so far? Okay. So we got that. And okay, yeah, now sub in. So then sub into the differential equation now. So then we get dy dx. You guys the product rule here again, right? So derivative of the first part, that's u prime. You keep the second part, plus, now this time you keep the first part, you multiply the derivative of the second part. So the derivative would be what here for this? It's just using the power rule to take the derivative. Yeah, negative 2x to the negative third, right? Times negative 2x to the negative third. Okay. So yeah, that was this part right here, dy dx. Now plus, now I'm going to use negative exponents here again. So that's 2x to the negative first. And then the y was this here again, u x to the negative second. Right? And equals. So I'm just substituting in here. And I wrote that as 2 to the negative first here this time. Okay, substitute. And then over here, now I can remember to do substitution right over here now. This is what, x. Now the y then is this here. So that's u times, okay, so x times then, what's the y? The y was u x to the negative second raised to the negative third then. Let's get this here. Okay, anything there so far? Did I do that right? So I was looking at this here. I wrote x, y to the negative third here. And then so I have x times then the y, right? The y is this. And so I put that here. Okay, so anything there so far in that? Now, once again, hopefully, if this is going right, these should cancel, right? You see this guy here and this guy here, right? But exponent, you add your exponents here, right? So those actually cancel out. Okay, so that will cancel that. Okay, so then we got what? U prime x to the negative second is equal to, that's x. And then here, I guess I'll just, use the exponent rules. So that'd be what? That'd be u to the negative third, and then x to what power? Positive 6. So right, yeah, x to the positive 6 there, right? X to the positive 6. Okay, so you got that. Okay, so then basically here, I'll try the u prime by itself, move the x squared over. I can multiply both sides by x squared. So you get u prime equals, if I count those up then, if I multiply both sides by x squared, that would be 7, 8, 9, I think is x to the 9th. Is that right? So both sides by x squared, and I count them up. I think that's it. And then now then I'm going to get to u the other side here. So basically it looks like this here now, right? I get du dx is equal to u to the negative third x to the ninth. Okay, like that. Okay. And then, so then when I separate it, that becomes what? It becomes u cubed du equals x to the ninth dx. Because it's separable there now. Okay, and then integrate both sides. Okay, anything there so far? Okay, now integrate, so that becomes what? 1/4 u to the fourth equals, and then that'd be 1/10 x to the 10th plus c. Okay, now solve for, you want to try to solve for u here now, right? So I multiply through by 4. Okay, so then go through by 4 here. That would be what? I get u to the fourth equals, that'd be 2/5 x to the 10th plus 4c. Can I go through by 4 here? Okay. Now, anything there so far? Now, tricky thing here a little bit. We're trying to solve for u. So I'd have to do what here? I have to take a fourth root to do that. Okay. But there's actually, when you do a fourth root, it's like a square root. There's like a plus or minus possibility when you do that. If I take the fourth root of both sides. Okay. But maybe if I write them both for a minute here. Maybe I'll just write them both down for a minute. So you get this here. So u would be plus or minus this, right? It'd be plus or minus this here. Okay. But also there was an assumption here. I had an assumption earlier that y was greater than 0 here. Now, what does that mean? If y is greater than 0, where is my, here it is. Okay. This is our thing right here, right? Y is equal to u x to the negative second. If I assume y is greater than 0, okay, if y is greater than 0, that means that, and this is going to be greater than 0 always here, that this part, the u has to be greater than 0 as well, right? If y is greater than 0, like my assumption was, that then the u is greater than 0. So if with that assumption there, if I'll drop off the negative one. I'll explain that here. Kind of write that out. So since y is greater than 0 and y is equal to u over x squared, must have u greater than 0. So if u is greater than 0, then it's just the positive root there. Okay. Now, the reason I mentioned that too, let me finish it up here first. So now we got this. Okay. So with the assumption y is greater. Now, if you didn't have the assumption y is greater than 0, then you'd have like a plus or minus here. And then you put the u back in front up here. But anyway, now recall this, that y is equal to what? U times, what was our function there? Is it x to the negative second? Okay, so we got then y is equal to, and then that would be, I'll say x to the negative second times the square root of 2/5 x to the 10th plus 4c, like that. Or in other words here, I can move the x to the negative second down to the bottom. So this would be a function here, this function here, then that'd be the, assuming y is greater than 0, okay, it would look like this. Now, like I say, if you didn't have the greater than 0 part for the y, then you would just have, it'd be like a plus or minus in front of here, you know, if you didn't have that extra part there. But okay, so end up with this here then. And by the way, then this 4c, okay, this 4c, you can call that under a constant if you want. Okay, so if you want to at this point, you know, if you don't want to deal with the 4C there, you could kind of lump it. Now, I'll lump it here now. Let's call it C, right? So you could think of like this too if you want. But this would be okay here, though, if you leave it like that too. Or this is okay here even if you leave it like that. So anything there? Okay. One thing I will mention, sometimes here on these, you might have an initial value problem, right? This was not an initial value problem, but you might have an initial value problem here with this. You know, you might say like y of 1 is equal to 8, for example. Okay, and then this part may not be here. This assume y greater than 0 part. Okay, but what you would do then is from the initial condition, you would assume you're going to deal with positive y's. Okay, so you might be given an initial condition like this, and then when you're down here make a decision, you know, at this point you're trying to decide, do I use the plus or the minus here? Okay, then you might have to look at the initial condition to see, okay, which one makes sense. Okay, does that make sense? Right, so there might be an initial condition here like this, and then that might help you choose the sign here. When you're solving for the u, you can choose the sign that way. So, okay, so I won't graph it, but that should be, if you graph it out, it should follow the slope field and everything for different C's. So, actually, maybe I will graph it. Let me just graph it out quickly here. I just noticed the time. But if I graph it out quickly, here's to see it. Let's look back here. Okay, so delete this out. Delete this out. And slope field here. Now, what would be the slope field for this one? Say dy dx equals, was it x over, okay, so x over y cubed minus, was it 2, minus what? 2y over x. Okay, thank you. 2y over x. And enter. Oh, there's the slope field. That's interesting. More interesting one there. Okay, now our solutions then, what we said, y equals is 4th root. So I guess I do like this, I think. 2/5, yeah, try again, 2/5 x to the 10th plus c, or I'll say plus c. You could say whatever, I'll just say plus c here. It'll do plus c, okay, and then divided by x. Oh, I didn't do the, darn it. That okay. Yeah, let me fix it. 1/4 power. I think it's I got to do the roots on there. It might be a fancier way. And then divided by x squared. I hope this one works. Let's see. Let's get this here. What do I think? I believe it. Let's see. You notice we're just getting positives here because I didn't put the plus minus in front. We're getting y greater than 0 here because of that restriction. Yeah, it looks pretty good. So, right. So if you had like an initial value problem, right? If you had like y of 1 was equal to 8 or something, or if you had some initial value problem like over here, you had a point, then you'd have to pick. It'd be this part over here. If you had some initial value problem, right? But then you can move this around. There's some of the different curves here then. Yeah, so you get all of them here above. I'd have to change my constants to a bigger range, I think. But you should be able to get all the solutions there, you know. Okay, let me change it. Let me say it's like negative 50. I don't know. See what this does. Negative 50 to 50. See if I can get some more of them here. Can I play it? What did I do? I think I broke it. I don't want to animate. I just want to. Oh, okay, play. I didn't like it. I think I broke something. Oh, is that my problem? Yeah, that's not good. Thank you. It's not. There we go. Yeah, so anyway, there's solution curves there, and then I think you get more of them here. You see how it's going out there, but you got to have big numbers to get it. But these are all the positive solutions here. So make these like -1,000, positive 1,000. You'll get more of it. But anyway, any questions in that?
I was wondering.
Yeah.
Square rooting to get rid of the
Actually, we're fourth rooting. We're not square rooting. Okay, so it's fourth root. So if you have like a u to the fourth, right, you're going to take the fourth root. So did I write square root there? I should have did I put an index? Maybe I didn't put the index in. Oh, my bad. You're right.
Isn't a fourth root like 4?
Yeah. I totally didn't do that. There should be a little 4 here. These should be fourth roots. Yeah, my bad. I totally forgot to put the fourth root in there. It acts like a square root there. You have to have the plus minus in front. Right. Okay. Good catch. So anything else there on that? Okay. So and actually we got through Bernoulli. So you should be able to do, there's homework on the Bernoulli now. You should be able to do the Bernoulli homework. Okay. And then next time we'll work on the next section in there. So okay. So let me stop there.